Welcome to CSAI Think Tinker Learn. This is part of my System Design Essential series. The goal here is to give you a solid mental model of system design topics. We're breaking down document stores and schema patterns today. This is a concept first introduction to help you build your system design foundations quickly. If you want to see a deep dive on the trade offs or a specific case study, let me know in the comments. You can find the full article and technical blueprints on our companion website. Link again is in the description. Now, these videos are kept at a very high level to provide a general framework. If you want a detailed video on specific details like MongoDB internals or sharding strategy, just ask. And let's now pull the mechanics apart for this topic. The debate between relational and document databases isn't a war, it's a spectrum dictated by our access patterns. SQL tables are the gold standard for fixed schema and full asset support, perfect for financial ledgers. However, the industry hit a wall in the mid 2000s when single PostgreSQL instances couldn't handle millions of writes per second. This birthed Document DB like MongoDB, which favored dynamic schemas and seamless horizontal scaling for rapidly evolving catalogs and hierarchical data. The first decision you'll face is embed or reference. I like to call these the staple versus the sticky note. Embedding the staple is blazing fast because it requires one read and zero joins. It's best for bounded data that is always accessed together. Referencing the sticky note is normalized for clean normalization for large shared data that requires independent updates. Beware the staples danger. If nested data changes frequently, you might have to update a million documents, leading to stale data sync issues. How do we handle mixed entities like a search interface for players, coaches, and referees? We use the polymorphic pattern. Instead of a monster table with 1,000 null columns, we use a single collection with a type discriminator field. This routes your application logic to the correct class instantly. It keeps the collection lean while allowing for schema-less flexibility without descending into chaos. E-commerce catalogs often have unpredictable fields, like laptops have RAM specs, while shoes have sizes. Trying to index every custom field is a maintenance nightmare. We tame this via the attribute pattern. We restructure specification into a predictable key value array. This allows a single compound index to handle the entire catalog, preventing a bloated schema and saving your system's memory footprint from exploding. While dealing with time series data like 10,000 IoT sensors, you can easily generate 864 million documents daily. This is an n plus 1 explosion. We fix this with the bucket pattern. By pre-aggregating values like min, max, and average at write time into a 1 hour window documents, we can achieve a 3600 times reduction in document count. This eliminates expensive read time aggregations and make your dashboard incredibly snappy. Every architect must protect the average case from the celebrity outlier. A viral post or a best-selling book can blow past normal array limits, dragging down the performance of the whole collection. Since MongoDB has a 16 MB BSON limit, we add a has extras equals true flag. The application absorbs the complexity by routing to a dedicated overflow collection only when that flag is tripped, keeping the standard document small and fast. For read-heavy systems like movie review sites, calculating the same average rating 100,000 times a minute is a waste of resources. We use the computed pattern. We pre-calculate the aggregation and store the result directly in the patent document. By shifting the computational load from the read side to the write side, we ensure that the most frequent operation, viewing the page, is as cheap as possible. Pure referencing requires too many database cells. Pure embedding wastes space. The middle ground is extended reference. We embed only the hot fields like a customer's name and the current address directly into the order document. This isn't just an optimization. It actually encodes historical business logic. If a customer moves next year, the historical order still contains the address while the package was actually delivered. Evolving a schema in production is dangerous. Never do downtime inducing bulk migration on active collections. Instead, embed a schema underscore version field from day one. This allows for lazy migration. You upgrade individual documents on their first read, while a low priority background batch job eventually clean up the rest. This keeps your application code from becoming a defensive mess of if-else statements. NoSQL indexing requires deliberate intent because you don't have an ORM nudging you. Partial indexes are a massive win for performance. They save RAM by only indexing active data, like pending orders, while ignoring millions of rows of historical noise. This keeps your indexes small, fit in memory, and prevents the dreaded collection scan. Let's look at the code review warning zones. If you see massive arrays, bloated guard documents, or single massive collection holding unrelated entities, you're looking at anti-patterns. Flexibility is not an excuse for chaos. Use the pattern we discussed, bucket, extended references, and polymorphic discriminators to separate logically distinct entities and keep the engine running smoothly. This brings us to the query-driven design framework. In a relational world, you model entities first. In NoSQL, that is the wrong way. You must identify the critical read path first. Does your query need mixed entities? Use polymorphic. Is it time series? Use a bucket. Is the document 10 times larger than average? Use the outlier pattern. Know the pain point, then choose the pattern. In a system design interview, look for these high signal answers. Why NoSQL? Because of schema evolution velocity and horizontal scaling. Why the 16 MB limit? To protect memory during RAM heavy processing. How do you migrate? Zero downtime, lazy migrations. Should you embed or reference? It depends entirely on the query. Being able to explain the why behind these trade-offs is what separates senior engineers from the rest. Schema flexibility is power, but governance is how you wield it. Design for the query, protect against the outlier, and build systems that survive scale. Now, I have a question for you. What is the weirdest schema workaround you have ever had to implement to stay under the 16 MB BSON limit? Let me know in the comments. If this episode helped you, please like, share, and subscribe to CSAI Think Tinker Learn. Check out the site for more essentials. Thanks for watching, and I'll see you in the next one.